Welcome to Organic Chemistry Online. My name is Tanya Hojeri and I'll be presenting this video for you. In this lesson we are going to talk about reactions of ketones and aldehydes with amines or alcohols. Ketones and aldehydes reacts with primary amine and secondary amines, and the reactions with primary amines and secondary amines yields different products. So let's look at the reaction of a ketone or an aldehyde, saying this R here is either an H or carbon chain, alkyl or aryl. The nitrogen first attacks the carbonyl, double bond breaks, and we will have O minus, prime, prime, and H, R. Since we have here nitrogen with the 4 bonds, it will hold a positive charge, and we can see that this compound here will have a negative and a positive charge. The second step, we can either think about it as a proton transfer, where a proton transfers from a nitrogen to an oxygen, or we can think about it as an oxygen getting protonated and the proton is getting deprotonated from one of the species in the solution, for example either the amines or the oxides around. The product of the first proton transfer is OH on one side, prime, prime, and H, R. The second step is the nitrogen making a double bond and kicking out a hydroxide, and now we end up with a carbon double bonded to a nitrogen, but the nitrogen will hold a positive charge. Upon deprotonation from a base, where the base might be also the amine, because amines also act as bases, we end up with a product that's called an imine. Where the imine, we still have an sp2 carbon, and instead of carbon double bond oxygen, it will be carbon double bond nitrogen. So primary amine, where we have R and H2, when it reacts with a carbonyl, it's always going to give an imine. That's the key point. In the presence of the two hydrogens, and we always have a byproduct of water there, because the oxygen and the two hydrogens are eliminated to produce water as a byproduct. Now when ketones and aldehydes react with the secondary amine, because we didn't have two protons here, so that's what happens throughout the mechanism. Let's look at the mechanism. First step, the same as before. And then we have a proton transfer. And then the nitrogen makes a double bond, makes out a hydroxide. And now, as we can see here, that this nitrogen has a positive charge, but then the 2R, there's no hydrogen to eliminate. This intermediate here is called an iminium intermediate, and instead of staying in that intermediate, a base comes in, pick that proton, make a double bond, and break that double bond, and then we form a species called enamine, ene, and amine, and the double bond is directly next to the amine, so that's what we call it, enamine. So as a conclusion, primary and secondary amines react with ketones and aldehydes, but tertiary amines, they don't, because they don't have a hydrogen on them. And there are other reactions that we call them derivatives of amines or ammonia, And when they react, they form different functional groups. For example, whenever we have hydroxyamine, you can see that there's the primary amine there, which means the hydroxyamine, anytime it reacts with a ketone or an aldehyde, it forms normally a compound called an oxime. We have hydrazine, one of the two nitrogens, it doesn't matter. It's also a primary amine. Then when a hydrazine reacts, it forms a hydrazone. And you can see that in this reaction, we have a 3 nitrogen. But these two amides, they are not amines because the two electrons here are part of the resonance. So the only amine that would react with a ketone is this is here the primary amine, and this amine would react with a ketone. And the product of this reaction will be semi-carbazone. Now, if we recall from last lesson that also ketones and aldehydes react with alcohols in presence of acid catalyst to form ketones and acetals. For example, if you have that ketone here, and then we add methanol in then acidic conditions, then the product will be OCH3. CH3, the double bond opens, and then we form an acetal, or in this case it's a ketal. If you have an aldehyde, like this benzaldehyde, and also the double bond will open because you have ROH here, you will have OCH3, OCH3, and this is here is an acetal. Same in this reaction, there's the carbonyl, and we have alcohol in presence of catalytic acid. Then the product of this reaction will be OCH3, OCH3, and it's going to be a ketal. And sometimes the two alcohols are connected, like in this one, in ethylene glycol, and then the product of this reaction would be a cyclic ketal. Now, cyclic ketals, those here, are important in synthesis. And why they are important in synthesis? Because when we have a ketone, the carbon there, it's an electrophile, and it reacts with any nucleophile. But when the carbon is an acetal or a ketal, then this one here is unreactive carbon, which means it won't react with a nucleophile. So, for example, where do we use those? We call them protecting groups. Why do we call them protecting groups? Because let's say we are using acetylide ion. We already know that acetylides, they react with alkyl halides, and they also react with carbonyls. So in this case, if I want this part of the molecule to react, and I don't want this part to react, I don't want this to react. So I want the total product, in this case this is the aim product. That's the aim product. How can I get that aim by acetylide? If I used acetylide without the protection, both of them, they would react with acetylide. But if I protected, which means the first step, I protect the carbonyl, and then the alkyl halide is still there. Now the acetylide here, it only reacts with the alkyl halides, and it won't react with a ketal. So what happened, I am actually selecting one side of the molecule to react and the other side to stay intact. And now we deprotect by adding water and acid, and we end up with the aimed product where only the alkyl halide reacted but the ketone did not react.